Look up at the stars tonight. You'll see countless dots of light scattered across the sky. But what if I told you that hidden out there, among them, are invisible giants that can devour anything in their path, bending the very fabric of space-time? These mysterious cosmic monsters are black holes, and despite their reputation for being dark, they might hold the secrets to some of the universe's greatest mysteries. Today we're going to unlock the mystery behind these enigmatic objects. How do they form? What's it like inside? And what have we discovered about the most famous black holes, like the one in the center of our own Milky Way galaxy, Sagittarius A? Buckle up because we're about to explore one of the most mind-bending phenomena in the universe. At its core, a black hole is a region in space where gravity is so powerful that it warps space-time to the extreme. Imagine this. Space-time is like a stretched-out fabric. A planet or a star sits on this fabric and causes it to curve. But what if you took something with an infinite amount of mass and squeezed it into an infinitesimally small space? The result is a black hole, a point where space-time is so distorted not even light can escape its grasp. Black holes are born from the violent deaths of massive stars. When a massive star reaches the end of its life, it goes out with a bang, a supernova. This explosion blasts the outer layers of the star into space, but the core is left behind. If the remaining mass is large enough, around 20 times the mass of our Sun, the core collapses under its own gravity, becoming infinitely dense. This is the birth of a black hole. At this point, the matter has nowhere else to go. The core becomes a singularity, a point in space with zero volume and infinite density. The event horizon, the black hole's boundary, forms around it. Picture this. A black hole's event horizon is like a cosmic one-way street. It's the point of no return, where gravity becomes so intense that it literally drags everything inward. If you were to approach a black hole, the closer you get, the harder it would be to escape. Once you cross this invisible boundary, even light, which travels at a mind-boggling speed, cannot escape. At this point, the black hole is effectively invisible to the outside universe. Now here's the catch. What happens beyond the event horizon? That's the greatest mystery. At the very center lies the singularity, where the laws of physics break down. It's where space-time becomes so warped that matter is crushed to infinite density. Imagine trying to understand an extreme version of gravity and time. It's a place where our current understanding of science stops making sense. Let's focus on one of the most famous black holes, Sagittarius, a star. It's a supermassive black hole located in the center of our own galaxy, the Milky Way. With a mass roughly 4 million times that of the Sun, it's an incredibly powerful force. But despite its massive size, it's relatively quiet. Unlike many other supermassive black holes that are constantly devouring matter, Sagittarius A is currently in a state of hibernation. However, it still exerts an enormous gravitational influence on nearby stars and gas clouds, causing them to orbit it in intricate patterns. Thanks to the way stars move around this invisible object, we know Sagittarius A star is there, lurking in the heart of our galaxy. In 2019, scientists did something once thought impossible. They captured the first ever image of a black hole. This wasn't just any black hole. It's located in the center of the galaxy M87, about 55 million light-years away from Earth. The black hole itself is 6.5 billion times the mass of our Sun. The image showed a dark circular shadow surrounded by a glowing ring of gas and plasma, which was heated to millions of degrees as it spiraled into the black hole. This groundbreaking photograph was the result of an incredible collaboration of observatories around the world, called the Event Horizon Telescope. So how do we spot black holes if we can't see them directly? We rely on their effects on surrounding objects. For example, when a star orbits an invisible object at high speed, or when gas is pulled toward a black hole, it emits X-rays and other forms of radiation as it's heated up. By observing these emissions, scientists can detect the gravitational pull of a black hole. Perhaps one of the most exciting breakthroughs in recent years came in 2015, when scientists at the LIGO Observatory detected gravitational waves, ripples in space-time caused by the collision of two black holes. These waves carry information about the objects that created them, and they've opened a whole new way of studying black holes. For the first time, we were able to hear the collision of two black holes, and it was the sound of the universe itself, a profound moment in astrophysics. One of the strangest paradoxes in black hole science is the information paradox. Quantum mechanics tells us that information about anything that falls into a black hole should be preserved, but the black hole seems to erase everything that crosses its event horizon, which would violate the fundamental laws of quantum physics. So, where does the information go? Some scientists suggest that black holes may not destroy information, but instead encode it in subtle ways, but the question remains unresolved. Stephen Hawking proposed a theory that black holes might not be completely black after all. He suggested that quantum effects near the event horizon cause black holes to emit tiny amounts of radiation, known as Hawking radiation. Over incredibly long periods, this radiation could cause black holes to lose mass and eventually evaporate entirely. If true, this would mean that black holes have a lifespan, and one day they might vanish. But Hawking radiation is still theoretical, and we have yet to observe it directly. Could black holes be the doorway to another part of the universe, or even another universe entirely? Some scientists speculate that black holes could be connected to wormholes, theoretical tunnels in space-time that could allow us to travel across vast distances instantly. These ideas may sound like science fiction, but they're grounded in the equations of general relativity. While wormholes have not been observed, their existence is still debated by physicists, and black holes may hold the key to unlocking these cosmic shortcuts. Black hole research is evolving at an astonishing rate. In the coming years, new telescopes and observatories like the James Webb Space Telescope are expected to give us even clearer views of these cosmic monsters. As we continue to study gravitational waves and the behavior of stars and gas around black holes, we may uncover new black hole types or perhaps even discover phenomena we never thought possible. The frontier of black hole science is just beginning, and we're on the cusp of making incredible discoveries. To wrap up, black holes aren't just cosmic oddities. They are the ultimate laboratories for testing the laws of physics. From their formation in stellar explosions to their mysterious behavior at the center of galaxies, black holes challenge our understanding of the universe in ways we are only beginning to understand. With each discovery, we peel back a layer of the unknown, and who knows what we'll find next. If you've enjoyed this deep dive into the cosmic mysteries of black holes, don't forget to hit that like button, subscribe, and turn on notifications for more content about the universe's greatest secrets. What's your theory on black holes? Are they the key to unlocking time travel? Let me know in the comments below.